Lti System Analysis using Dtft. After completion, the students can able to demonstrate the ability to recognize, analyze and manipulate basic continuous time systems and discrete time signals, and to classify continuous and discrete time system to their linearity, time invariance, causality and stability. First topic is Lti system analysis using Dtft. Here in this, the output of the Lti system is given by the linear equation y of n equal to summation k equal to minus infinity to infinity h of k into x of n minus k. Let the system be excited by the sinusoidal or phase here, that is e power j omega n. Therefore, this can be given as x of n equal to e power j omega n, that is n varies from minus infinity to infinity, and hence the system is complex in nature and it has unit amplitude and frequency, and the frequency is omega, and the output is given by y of n equal to summation k equal to minus infinity to infinity h of k into e power minus j omega n minus k. And here we are splitting this into 2, that is the exponential term is splitted into 2. Therefore, when we are splitting, and again after splitting and rearranging the term, we are taking the term inside the bracket as h of omega equal to into e power j omega n. Therefore, h of omega can be written as summation of k equal to minus infinity to infinity h of k into e power j omega n, where h of omega is the Fourier transform of h of k, and h of k is the unit sample response, and h of omega is also known as the transfer function of the system. H of omega is complex valued function of omega in the range of omega varies from minus pi to pi, and the transfer function of h of omega can be expressed in pole of omega equal to modulus of h of omega into e power j into angle of h of omega. Modulus of h of omega is the magnitude of h of omega, and angle is angle h of omega, this is the angle of h of omega. Thus, we can analyze the system by using the Dtft. And now we are going to analyze the system using Z transform. The Z transform of impulse response is called the transfer or system function h of z. Then we can write this as y of z equal to x of z into h of z. And the general form of the Lcccd is given as summation k equal to 0 to n ak into y of n minus k equal to summation k equal to 0 to m bk into x of n minus k. And here we are just applying the Fourier transform in this Fourier transform in this equation, and therefore we are getting this equation as like this. Finally, we are computing the Z transform, that is h of z equal to y of z by x of z. Therefore, the Z transform is given by the analysis of this Z transform is given by this equation h of z, which is the system function or the transfer function of the given Lti system. Now we can see an example. Consider the system described by the difference equation y of n equal to the given the difference equation. Now we want to find the different system. We want to describe the system in the we want to describe this by using the differential equation. Here we know that the order is m, therefore n equal to 3, then m equal to 1, therefore the order of this is it is a third degree differential equation. Therefore, by using that we are just going to write the characteristic equation. From that characteristic equation we are finding the poles of this particular, that is we are finding the roots of that particular equation. Since we are having 3, n order is 3, therefore we are having 3 roots, and we are substituting the value in that particular equation, and finally we are simplifying by using the matrix method, and finally we are getting the impulse response h of n equal to minus 4 by 3 into 1 by 3 the whole power n plus 10 by 3 into n into 1 by 3 the whole power n plus 7 by 3 into 1 by 4 the whole power n. Here since we want to find the value of a0, a1 and a2, we are using the matrix multiplication for finding that value. And this is the possible questions in the analysis of Lti system using this discrete time Fourier transform. Thank you.